this is Algebra 2, Lesson 7-4, Properties of Logarithms. Now you can derive the properties of logarithms from the properties of exponents. For example, if you let x equal log b of m and y equal log b of n, you should write it in the notes. Okay, that's why there's a giant space there for me. Then by the definition of logarithms, m equals b to the x and n equals b to the y. So m times n, since they have the same base of b, is going to equal b to the x times b to the y. So m times n equals b to the x plus y, because that's the product property of exponents. So going back, log base b to the mn equals x plus y, which means log base b to the mn equals log base b of m plus log base b of n. We substitute x and y back into the equation. Okay, so that leads us to the properties of logarithms. The properties of logarithms are very similar to the properties of exponents because they basically follow the same basic pattern as the properties of exponents. For any positive number m and n, and b, where b is not equal to 1, log base b of m times n is the same as saying log base b of m plus log base b of n. That's your product property. Just like 3 to the third times 3 to the fifth is 3 to the third, 3 plus 5 or 3 to the 8th. Log base b of m divided by n is the same thing as saying log base b of m minus log base b of n. Okay, remember, in quotients of exponents, you subtract, same thing with logarithms. And then the power of an exponent taken to a power, log base b of m to the x power is x log b of m. Okay? Those three properties are going to be very, very important when we work with logarithms. So, you can use the properties of logarithms to rewrite logarithmic expressions. So if I have log 20, that's the same as saying log 5 times 4, because 5 times 4 is 20. So that would be log 5 plus log 4. Okay, here we go. Log 5 plus log 4. Log 5 to the x to the 9th power, since this is an exponent, it goes on the outside, so it becomes 9 log 5 of x. Log base 2 of 24 minus log base 2 of 3 means we're subtracting, which in actuality means we're dividing. So that would be log base 2 of 24 divided by log base 2 of 3. And 24 divided by 3 is 6. Actually, 8, not 6. So this becomes log base 3 of 8. Log base 3 of 5x to the 4th power becomes log base 3 of 5 plus log base 3 of x to the 4th, which becomes log base 3 of 5 plus 4 log base 3 of x, because this exponent ends up going on the outside over here of this logarithm. Okay, it's basically working a little bit with your logarithms. So, we're going to write each one of these expressions as a single logarithm by using the properties of logarithms. Okay, so I have log 4 5x plus log 4 3x. Okay? Since they're added together, that actually means that they're multiplying, doesn't it? So basically, log base 4 of 5x plus log base 4 of 3x is going to equal log base, and that because that's using too much space. That the above thing here is going to equal log base 4 of 5x times 3x, because when you're adding them, it's the same as multiplying, which becomes log base 4 of 15x squared. Okay? So that's writing that as a single logarithm. 2 log base 4 6 minus log base 4 9. Since we're subtracting, that's actually division. So I'm going to have, this will equal here, this will equal log base 4 of 6 squared, because this 2 goes on top of this 6 there, divided by 9. Okay, which becomes log base 4 of 36 over 9, which is log base 4 of 4. Because 36 divided by 9 is 4. That's writing as a single logarithm. Okay. You can expand a single logarithm to include or involve the sum or the difference of 2 or more logarithms. So we're going to expand each one of these logarithms. So what is log base 3 of 250 over 37 expanded since we're dividing, this actually means subtraction, doesn't it? So it means log base 3 of 250 minus log base 3 of 37. Okay? But 250 is the same as 2 times 125. Okay? So I'm going to have log base 3 of 2 plus log base 3 of 125 minus log base 3 of 37. Because all I did was I took 250 and I broke it down to 2 times 125. Okay. 125 is 5 to the third power. So I'm going to have log base 3 of 2 plus log base 3 of 5 to the third minus log base 3 of 37. Now, if you remember, 5 to the third is the same thing as saying 3 log 5. So last but not least, this becomes log base 3 of 2 plus 3 log base 3 5 minus log base 3 37. That is expanding that single logarithm back into its original logarithms. So it's really, really long and complicated, but the more you work with it, the better you get at it. So now we have log y divided by 3 all to the second power. Okay, so if I do that, I have, this becomes division is subtraction, so this becomes log, okay, and this is a natural, excuse me, a common log because it's base 10 because I don't give it a number. So log of y squared minus log 3. Now y squared becomes 2 log y minus log 3. Oops, I forgot this would be 3 squared because I have to distribute this square to both. So this would become like 2 log 3 in there. So it's 2 log y minus 2 log 3. I almost messed that up. Answer C. Log 3 and 9x to the 5th. Okay, so since it's 9 is multiplied by x to the 5th, that means multiplication is addition. So we have log base 3 of 9 plus log base 3 of x to the 5th. Okay, 9 is 3 squared, so that becomes log base 3 of 3 squared plus log base 3 of x to the 5th. So this becomes 2 log 3 of 3 plus 5 log 3 of x. Okay, but what is log 3 of 3? Okay, remember, we have the same thing here and here. They cancel themselves out and become 1. And 1 times 2 is 2. So to simplify this one step further, this becomes 2 plus 5 log 3 of x. If you didn't recognize that, I would really not penalize you too much because it's hard to remember that if you have a log to the same base as its number, it basically cancels itself out. You'll remember that eventually. Okay, so log 7, a to the third, b to the fourth. That a to the third, b to the fourth is multiplication, which means addition. So I'm going to have log base 7, a to the third plus log base 7, b to the fourth, which is going to be 3 log 7, a plus 4 log 7, b. That's actually one of the easiest ones we have in this entire section here. Okay, now, you've seen logarithms with many bases. We had log base 3 here, we have log base 7 here, we had log base 10 in problem B. So we have, in these 4 problems here, we have 3 different bases. We have base 10, base 3, and base 7. Okay. Now, you have seen logarithms with a lot of bases. The log key on a calculator finds log base 10 of a number. So if you just look at the LOG key, okay, it may be capitalized, it may not be capitalized, depending upon what type of calculator you have. To evaluate a logarithm with any base, we can use what's called the change of base formula. The change of base formula is a nifty little formula that allows us to change bases for any logarithms. For any positive numbers, m, b, and c, with b obviously not equaling 0, and b not equaling 1, and c not equaling 1. Okay? Log base b of m equals the same thing as saying log c of m divided by log c of b. So if I have log 5 of 100, okay, it's the same thing as saying log of 100 over log 5. Okay? Log base 2 of 100 is the same thing as saying, I could say log base 5 of 100 over log base 5 of 2. Notice, I can put anything in here as long as I keep it the same on the top and the bottom. That's all they're really showing you here. Okay? Is they're showing you as long as you keep the logarithm the same on the top and the bottom, whether it's base 10, as this one was. This was one they changed to base 10. This one they put back in log 5. Okay? As long as it's the same on the top and the bottom, it works. So last but not least, if we have log base what of 100 equals log 2 of 100 over log 2 of 3. So what has to go here? This has to be a 3 because we have 100 over 3. They're the same log, so it's got to be 100 and that's going to be 3. Okay, so there are two methods. Okay, there are two methods to evaluate a log. If I have log base 8 of 32, okay, I could use it with a common base. Okay, that's the first thing. I know that 32 is equal to 2 to the 5th power. Okay, so I know that log base 2 of 32 equals 5. Okay. Now, since I also know that 8 equals 2 to the 3rd, since 2 to the 3rd equals 8, I know that log base 2 of 8 equals 3. Since I know both of those things, since I know log base 2 of 32 equals 5 and log base 2 of 8 equals 3, I can use those with my common base because they have a common base of 2 here. So I can have log base 2 of 32 divided by log base 2 of 8, and that will equal 5/3. And because log base 2 of 32 is equal to 5, and log base 2 of 8 equals 3, so I know that log base 8 of 32 equals 5/3. Probably not the easiest way. It's helpful if you don't have a calculator to use this way, because if you don't have a calculator, you really don't have any of the method. You have to use the common base. If you do have a calculator, it's a whole lot easier. Just use the change of base formula. Because the change of base formula basically says this. If I have log base 8 of 32, I can change this to make it log of 32 over log of 8. And if I put that in my calculator, log of 32 divided by log of 8, okay? And I always put mine in parentheses, I don't know why. And I just skip the putting the base 10 in there. I just leave it blank. And it only puts that base 10 in Inspire. Okay, and if I do that, log 32 divided by log of 8 equals 5/3. Okay. If you use the 84 and you do log of 32 divided by log of 8, it's going to give it to you as a decimal. You're going to have to change it back to a fraction. But it will change it back to a fraction quite easily on my end. So there you have it. There's two ways of doing it. You can use the change of base formula with a common base, or you can just use the change of base formula. It's a little easier to use the change of base formula with a calculator than it is to use it with a common base. Okay? And that is these logarithms.